Good morning, everybody. Welcome to Tuesday. I hope you all had a nice long weekend. I know that I got to relax too. There was actually 2 days where I did nothing. That hasn't happened since last summer. So it was great. So anyway, uh, we are now going to talk about combinations and how they compare with permutations. We've already spoken about permutations. What are permutations? Permutations are ways of counting things up where the order in which choices are made are important. These are the permutations right here. What might be some examples of permutations? How about a PIN number? Some people, still need a PIN to get into their phone. Well, a lot of people need to get some kind of PIN. If you don't do that code or that PIN in the correct order, you're not getting into your phone, right? Okay. How about you have a car, a piece of paper. The top line is for president. The second line is for vice president. The third line is for treasurer, and you're voting for student council. If you want Joe Bag of Donuts to be the president, you're not going to vote him in the second line. You're going to vote him on the first line. All right. So, or Joanne Bag of Donuts. There are sometimes ways of counting things up when the order of that the choices are made is not important. These are called combinations. Okay, and what's an example of counting things up where the order is not important? Suppose we are, choosing 5 committee members from our class to decide how much homework to give each night. And I'll come on screen for this one. Suppose I am choosing, I don't know, Anton over in the corner, maybe Rohan right in the middle of the class. I'm looking at you, Rohan, and maybe Gabby over there on this side of the class. Now, does it matter if, and I know I said 5 committee members, I could just say 3, but does it matter whether I choose Gabby first, Rohan second, or Anton third, or if I chose Anton first, Gabby second, and Rohan third, as long as they're all in the same committee? No, it doesn't matter. That's the difference between a permutation and combination. With a permutation, every time you change the order, you get a brand new permutation. That's the definition of it. However, if it's the same 3 objects, the same 3 people, it does not matter what order you select them in. It's the same combination of 3 people. That is the point. All right, so this might be the most succinct way that I could describe to you the difference between a permutation and combination. Here we go, ready? Let's take the letters A, B, and C. Now I can arrange them A, B, C. I could arrange them A, C, B. I could arrange them B, A, C and B, C, A. I could arrange them C, A, B. And I can arrange them C, B, A. Every time you change the order, you get a new permutation. So how many distinct permutations are there here? There are 6 distinct permutations here. Because I changed the order 6 different times, I get 6 different permutations. However, because they are all the same 3 letters, it's the same combination of 3 letters no matter what order they are in. So because I'm only using A and B and C and not any other letters, there's only one combination of those 3 letters because the order is not important. Ladies and gentlemen, that is probably the quickest way I can describe for you the difference between a permutation and a combination. Change the order, get a new permutation. As long as they are the same objects, doesn't matter what order they're in, it's the same combination of objects. So as a general rule, there will always be more permutations on a number of objects than combinations on the same number of objects. Because of that, I'm going to go over the formula once again for permutation combination. NPR is the formula for permutation, and CR is the formula for combination. Now, I did go over the formula for permutation the other day. It's n factorial divided by n minus r factorial, where n is the total number of objects and r represents the number that you're choosing from the total. From the total. Okay, so good news. The formula for a combination is almost identical So the formula for a permutation, n factorial divided by n minus r factorial. However, because there will always be fewer combinations, I need to divide by one extra thing. And the one extra thing I divide by is an extra r factorial. That is what differentiates a permutation from a combination. In practice, what if I were to do 5p2 and 5c2? I guess this would be 5 factorial divided by 5 minus 2 factorial. The last time I counted 5 minus 2 was 3. So this is 5, 4, 3, 2, 1 divided by 3, 2, 1. The 3's, the 2's, the 1's cancel. I'm left with 5 times 4, which is 20. How about 5c2? By definition, that would be 5 factorial divided by 5 minus 3 factorial, but then times an extra r factorial. So what is r? It's the 2. Oh, 5 minus 2 factorial, my bad. I had 3 on the brain. 5 minus 2 factorial, and then by an extra 2 factorial. So this is a 3 factorial, and this is a 2 factorial. So this on top is still 5, 4, 3, 2, 1. In the denominator, I've got the 3 factorial and the 2 factorial. So I've got 3, 2, 1 for the 3 factorial, and 2 times 1 for the 2 factorial. So 3's, the 2's, the 1's cancel. And I'm left with 5 times 4 on top, 2 times 1 on the bottom. 2 goes into 4 twice. And I'm left with 5 times 2, which is 10. So while there are, that's an ugly 10 right there. Let me rewrite that. 10. There we go. So while there are 20 ways to choose 2 out of 5 objects when the order is important, there's only 10 ways to choose 2 objects out of 5 if the order is not important. Fundamental difference. Mr. Colodi, will the number of permutations always be double the number of combinations? No, it will not always be like this. That's just what it was in this particular example. Great question, though. All right, so here we go. For all of these examples, I'll be absolutely honest, you just need to decide whether order is important or order is not important. A company advertises 2 job openings, one for a copywriter and one for an artist. So those are 2 completely different job descriptions. If 10 people were qualified for either position, apply. In how many ways can these positions be filled? All right. So it says 10 people who are qualified for either position. So if you're applying, and I know they are different positions, but you can be a copywriter or you can be an artist. I know they're different, but it just says either one, so it doesn't matter. So good, you just want to work, especially in this environment that we're working in this world right now. So order important, I'm going to say not important, because they can work for either position. All right, so that's either 10P2 or 10C2. And because order is not important, it's going to be 10C2. Just for these examples, I'm going to use the calculator for 2 examples, and then that's it, or maybe 3. Where's my calculator? Where did it go? Wait a second here. All right, hang on one second here. I'm going to go to here. Let me get out of this. Sorry, I know you can't see what I can see, but let me get to the sum right now. There it is. Apologize for the delay. So I'm going to do 10, then go to math, then go over to prob. But now look at option number 3 and CR. You could just hit number 3. So 10C2, and that equals 45. All right. There we go. A company advertises 2 job openings for computer programmer, both with the same salary and job description. In how many ways can the jobs be filled if 10 people apply? So once again, now it's even more of the same. I know they can apply for either position there, okay, but both with the same salary and the same job description. So I'm going to go with either 10P2 or 10C2. I'm going with 10C2 here again because it's the same salary and same job description. Order, not important as well right there. So that's the same 45 ways to do things. Okay. How many ways can a club with 10 members choose a president, a vice president, and a treasurer? So you got 10 members, you're choosing 3. Will that be 10P3 or 10C3? Interesting question right there. Well, because they are 3 distinct positions, that's going to be 10P3. I will do one more share with the calculator, and I will do 10. I'll hit math. I'll go over to prob, and I'm going to go to option 2 this time. 10P3. Hit enter, and I'm at 720 possible ways to do these things. So 720. How many ways can a club with 10 members just choose a 3-person committee? Ooh, so that's just like Anton, Rohan, and Gabby. Doesn't matter what order I choose them in. By the way, a committee is a buzzword for combinations. If you see the word committee, pretty much guaranteed you're going to be working with a combination there. So that's 10P3 or 10C3? It's 10C3. Just letting you know that turns out to be 120, which is 6 times less than 10P3. So it's not always double. How many 4-letter words can be formed from the first 14 letters of the alphabet if all of the letters are unique? So because they're unique, that means the order is important. So would that be 14P4 or 14C4? That's going to be 14P4. And that's a lot, 24,024. Okay, number 6, how many 14-letter combinations, oh my gosh, I'm just giving it to you right in the word problem, can be formed from the first 14 letters? That's 14C4. So that's 1,001 possible combinations. Are you getting the hang of this? Is this starting to make a little bit more sense to you? Why don't we skip all the way down to number 11? Determine whether each situation involves a permutation or combination. Arranging 10 books on a shelf. Well, especially in the age of Zoom, you might be interested in what's behind you in your room. You may not even care, but I've seen a lot of people on TV care exactly what's on them. So I'm going to say that the order is important there. I'm just going to say P for permutation on this one. Selecting a committee of 3 from 10 people, that's just a combination. A hand of 6 cards from a deck of 52 cards. All right, I need you to all think about this for a second. I'm going to come on screen. When I deal the cards to you, do you have to pick up the cards and look at them in the exact order that I gave them to you? Of course not. You can pick up your cards and then rearrange them in whatever order you see is logical to you. So is the order important in which those 6 cards are dealt to you? No. So that's a combination right there. A guest list of 3 friends you have over for dinner. Okay, as long as they're the same friends, would it matter if you put Gabby first on the list, Anton second on the list, and Rohan third, or Rohan first, Anton second, and Gabby third? If they're all coming to have dinner with you anyway? It's a nice dinner party. No, it doesn't matter. That's a combination right there. If the order is not important, it's a combination. Before I go off screen, for one last time, I might do one last example. You should write your local congressman for this one right here, because you should be angry. All right, corny moment right now. But come to school each morning, or hopefully we'll come to school soon. What do? Well, you probably don't use your locker because it's so far from your classes, but at my school, Manville, I use my locker all the time. However, okay, you have to go what? To the right, then to the left, and then to the right with specific numbers. Okay, if you don't use those specific numbers, you're not getting in your locker, right? But what's it called? Your locker combination? It's a locker permutation, darn it. The order is important. It's not a locker combination, it's a locker permutation. I say, write your local congressman and senator and demand that it be called a locker permutation from this moment forth. All right, that's it. Okay, so anyway, let's just go down to the bottom right here. Using a deck of 52 cards, how many ways can a 5-card poker hand be dealt? We just said it doesn't matter what order you get those 5 cards dealt. So that's 52C5. And to wrap this up, 52C5 turns out to be 2,598,960. For those of you who are not familiar with 5-card poker, it is completely dependent upon the likelihood that something can occur. And so, you want to say goodnight, buddy? Yes, just all hints. I'm making this film at night, and you can say goodnight. And Griffin is also saying goodnight to Mr. Frodo, who is on my left. Hey, Frodo, say hi, Frodo. Yeah, yeah. All right, coming off screen for the last time. So, and so, all right, so now, that's it. That's all there is right there. If you're actually wondering the likelihood of, say, a royal flush, which is the most powerful card in the most powerful hand in that deck of cards, that's the 10, Jack, Queen, King, and Ace of the same suit. There's only 4 of them. So there's a 4 out of 2.6 million chance you're going to be dealt that hand, which is why it's the most powerful. Everybody, that's it. Have a great day. And if you have questions, ask me. See you.